This video is numbers 28 and 29 on 8-3 form G. We're going to start obviously with 28. A right triangle has a hypotenuse length of 10 and one leg length of 7. Find the length of the other leg and the measures of the acute angles in the triangle. Round your answer to the nearest tenth. Okay, so for this one, there's a couple ways to go about it. If we draw our picture, all right, we have a right triangle, the hypotenuse is 10, and one of the legs is 7. Now, it does not matter how you draw your picture, how you draw your triangle, where you put 7, what leg is 7, that doesn't matter. Okay, you just need to draw a right triangle and label it according to what they told you. Even if it's not drawn to scale, who cares? You're just using it for positioning to figure out what you need to know and figure out what trig function to use. So there's multiple ways to go about doing this. So they ask us to find, let's put these in a different color. They're asking us to find this length, and then we need to find both of those angles. Now, you could find the angles first and find the side length last. You could find one angle, use that angle to use trig to find the missing leg, and then find the third angle. It doesn't matter how you do this. I'm going to go ahead and show you, I'm going to use the Pythagorean theorem to find x, just to review the Pythagorean theorem for you in lieu of your quiz. But you most certainly could use inverse trig to find either z or y, and then use that information to find x if you chose to. But like I said, it doesn't matter, just as long as you get the correct answer. So let's go ahead and use the Pythagorean theorem just to kind of review that, since you have a quiz over that. Pythagorean theorem is the two legs squared added together is equal to the square root of the hypotenuse. So 7 squared plus x squared is equal to 10 squared. So 49 plus x squared is equal to 100. X squared, let's show some work here, minus 49 from both sides. So x squared is equal to 51. So when I square root 51, that gives me 7.1. So I square rooted both sides and got 7.1. So the length of x is 7.1. Or no, they didn't call it x, the length of the side length. That's what they actually called it. So there's that. If you need to see this in a different way, just shoot me an email and I'll tell you the setup at least. Maybe I won't show you the whole problem. If you need to, I will, but maybe just the setup would be all you need. Now, there's a fast way to do this too. Well, we need to find an angle first before I get into that. So let's take a look at, it doesn't matter which one you choose to find first. Let's just, for the sake of this, I'm going to find z. Okay? And at this point, it's tricky because you have choices. And so in this case, you would stand at the angle that you're given, or actually you want to find. And you can really use whatever you want. Now, my recommendation is on a test, I would never use the side length that I found because there's a chance I got it wrong. And we're going to just apply that method here. So I was given 10 and 7. Okay, so let's, just pretend like you didn't find the 7.1. It wasn't part of the problem. Let's just say they wanted you to find this angle. That way, if you use the one that you found, and if let's say 7.1 was incorrect and I used it to find that angle z, well then I get 2 questions wrong. So let's just pretend for the moment that we don't know that that's 7.1. So now we're going to use 10 and 7. So 10 is my hypotenuse. This is my adjacent. I'm looking for an angle, so I know I'm going to use the inverse trig function. So cosine, because ka. So adjacent and hypotenuse tells me cosine, so the cosine of z is equal to a first, 7 over hypotenuse 10. So I take the second, let's back up a minute, take the cosine inverse of both sides. Those cancel. Z is equal to cosine inverse of 7 over 10. So in your calculator, hit second cosine, 7 divided by 10, and that gives you, Z is 45.57, and they wanted us to round all answers to the nearest tenth. So this would just be 45.6. Okay, so Z is 45.6. Now, okay, so we still need to find this angle up here. All right. I'm going to show you a setup if you didn't think or choose to do it this way, but there's a very easy way to find the missing angle of the triangle. But let's just pretend for a minute it slipped your mind before I tell you. You would stand here. And again, I would not use the 7. You could, but I would recommend not using the 7.1. But just so you're clear. I mean, well, actually, I don't even want to confuse you. So we're gonna again ignore 7.1 as was found. Okay, so this is still the hypotenuse that hasn't changed, but now 7 is the opposite, no longer the adjacent, because I'm no longer standing down here. Okay, so if you wanted to make a setup here, you could do the sine of y is equal to opposite over hypotenuse, and you would sine inverse both sides. But the very fast way to do this, without doing a trig function again, is you have a triangle. There's 180 degrees in every triangle, so you could take your 90 plus 45.6 plus y has to add up to 180. So you can add these two together, subtract it from 180, and that should give you your 44.4 degrees for angle y. Okay? Last one here, number 29. Similar setup, but a little bit different information here. A right triangle has an angle that measures 28 degrees. The leg opposite of the 28-degree angle is 13. Find the length of the other leg and the hypotenuse. Round your answer to the nearest tenth. Okay, so again, it doesn't matter what your triangle looks like. You just need to do exactly what they told you. So a triangle has an angle that measures 28 degrees. So here's my triangle. That's not a good place. I ran out of room. Here's my triangle. This angle is 28 degrees. All right, it says the leg opposite of the 28-degree angle is 13. So the opposite of that is here, so this is 13. We know that's a right angle. They want you to find the other leg and the hypotenuse. Round your answers to the nearest tenth. So for one of these, you have to use trig. Once you use trig, you can use trig a second time, or you can use the Pythagorean theorem. It doesn't matter which you choose. Okay? So in this case, and it doesn't matter which one you find first, which the hypotenuse or the leg. I don't know. Let's just find the hypotenuse first. So you would stand at the angle you're given. The directions told me that 13 is opposite from the 28 degrees. Your hypotenuse is what you're looking for. We'll call x. So the sine function is what you will use. So the sine of 28 over 1 is equal to opposite 13 over x. Cross multiply. You get x times the sine of 28 is equal to 13. Divide by the sine of 28. And when you do that, you get 13 division button sine 28. Then you get 27.69, which they want you to round the nearest 10, so you get your 27.7 there. Okay? And then now, if you were inclined to use trig again, alright, you are not finding the hypotenuse this time, you are looking for the adjacent, so you would use the tangent function. So you would do the tangent of 28 is equal to opposite, which is 13, over adjacent x. You cross multiply again, and that would give you x times the tangent of 28 is equal to 13. Divide both sides by the tangent of 28, and that would give you whatever the answer is of 24.4. If you wanted to use the Pythagorean theorem instead, assuming that you found the hypotenuse first, which we said was 27.7. I'm not going to do this, but I'm just going to show you that you could, if you didn't want to use trigonometry again, you could say 13 squared plus x squared is equal to 27.7 squared. If you found the hypotenuse last and found the adjacent side or the other leg first, it would be 13 squared plus 24.4 squared is equal to, I guess technically, c squared. And that would be your alternate way. Instead of using trig twice, you could use the Pythagorean theorem, and those are both setups depending on which side you chose to find first. Okay? Any questions, as always, shoot me an email. Talk to you later.